Okay, so good morning, everyone. It's actually great to be the first speaker and not one before the lunch. So we'll start about some things about networking. And we are in the midst of the revolution that actually we'll see the perspective in maybe many years from now, but we are in the midst of a huge transformation of the world. And we'll talk about this. So for me, from my perspective, all this starts with this move from phone being static to being mobile. I got this machine in my hands about 30 years ago, maybe a little bit more than 30 years ago, and I thought it's really cool things because I can talk to my kids, to my wife. I worked at Intel those days, so on the way, and I live in Israel, so it's 10 hours difference. So on the way to and from work, I could talk to my colleagues in the United States, which really opened up new ways of operation and communication. But I didn't realize those days that 30 years later, this machine will become something that you never leave home with. It's actually what Steve Jobs told to his engineers. I want you guys to design a machine that nobody would like to leave home without it. And now we use the phone for news, emails, gaming, social media. Sometimes we use it as a phone, and you can do it all even without leaving the toilet. So everyone now becomes a huge source of data. This thing generates an amount of data that nobody ever thought before. And data grows exponentially. And every year, or maybe even every half year, the amount of data generated doubles. So every year we generate as much data as was generated so far before. And data becomes a resource. What used to be oil in the 20th century is now data. And once you have an access to the data, and once you have the access to data in the efficient and productive way, you can do a lot of things, good things for yourself, for your business, and for others. And I have here a very short example of paradigm shift of getting the data. In 2007, Nokia was a huge company, very large company, about $150 billion worth. And those days, the iGo and the like navigation gadgets took off. So people started to use the navigation in their cars. And Nokia decided to get to this business as well. But in order to get to this business with the added value, they decided to build a navigation system that actually considers the traffic. To make it work, they need traffic sensors, so they gone off and bought Navatec, which is the European company. They had about 5 million traffic cameras across Europe. So with traffic cameras, you can know where the traffic is, builds up, and this way, by connecting this to your navigation software and navigation gadgets, you can actually navigate people around the traffic. So accidentally, actually the same year, in 2007, there was Israeli company started Waze. They figured out that they can get same data, which is traffic sensors, for free, by writing this application software, and every phone that runs this software actually generates the data to Waze, and pretty much the rest is history. So Waze figured out that they can get the data in a much more efficient way out there, and the rest is history. Nokia gone down in 5 years or 6 years to less than what they bought Navatec for, and Waze sold to Google for more than $1 billion. So once you figure out that the data is out there, and you find a way, efficient way to get this data to your hands, you can do a lot of good things for yourself and for community. So the storage, the disks, and the disk media evolved, and that's a whole other topic that I'll not touch too much on the media itself. But it turns out that there is enough disks to save and to store the huge amount of data is being generated. More than 70% of the data that is generated by the phones and the chats and so on and so forth are actually stored somewhere. And only small fraction of this data is actually ready to be processed. It's not the database, it's not the databases, it's unstructured data. Very little is being analyzed, and a huge amount of data is wasted in terms of it is not being used to generate the real information and real value. So there is a gap between the resources that are out there, and in many cases, as we have seen with the waste example, are for free. They're free or almost free to the point that we actually can use them. Okay, so to use the data is to process the data, and we used to write programs on our machines to take the data and convert it to the information, which running the application. But I think there is a challenging here. The growth of the data and growth of the CPU power are not aligned. Actually, the data growth is faster than even than Moore's law. And the CPU performance, if you look at the performance of the von Neumann machine, is not keeping up with the data and barely keeping up with the Moore's law. The good thing is that the network is there, and the network bandwidth and network performance are pretty much aligned with the data growth. Maybe it's actually related, but that's a different story. But so we have this and other technologies, and now we need to think about how to do it differently. And with gap growing, it means that we cannot do the evolutions anymore. Like electric light didn't come from the improvements of candles. We need to think outside of this box of what can and what cannot be done in order to improve our take advantage of this data that is being generated. And the CPU model, von Neumann machine model, is not good enough for us anymore. So in the 20th century, we took von Neumann machine, put people to program the machine, created the application and or service, so it gets the data, it generates the output. All good. Now we can't do this anymore. CPU doesn't keep up. So what we need to do, we need to use the data to generate the services itself. This is the artificial intelligence model, neural network model, how do you take the data and actually create the services using the data. The machine learns from the data to do the job, and the application or services are created by data itself. So when we create these services, we need to basically think it's outside of the computer. It's not a single individual processing unit, von Neumann machine anymore. It's the connecting different pieces of the network of machines and by the network and make them work together to create the services. It means take advantage, optimized across the data center, optimized across the cluster. And with IoT, we had this just debate discussion on the breakfast. It's actually optimizing even outside, looking at the whole picture even outside the data center. And it's all about efficiency, but it's not just efficiency. If you do the right things, we can do new things that we couldn't do before. It's not just doing the same thing faster. It's doing new things that we haven't done before. So one of the analogies is the ants. A single animal like this, insect like this, it can't do much. But many of them together, working together in a way that people don't really understand, at least I don't understand how does it work, they can build huge things. They build cities with the ventilation and the irrigation system and everything. This by connecting to each other, by working together efficiently, by linking together efficiently these resources, you can do things which is not linear extrapolation of one guy what it can do. So how do we optimize? First of all, we need to think about this paradigm that it's not a single programmer programs single machine. It's data programs the computer. You need to make machines that can learn from data. You need to make the machines that program themselves. You need to enable the data processing or computing, data processing everywhere. On the compute node itself, on the general purpose computer, in the network, and in the storage. Computing and storage network. And last but not least, security is a really interesting topic that we will touch a little bit, because once we have more data, we can understand more and we can know more, and it comes the security from crime to privacy to everywhere. Okay, so cloud is the different approach. It is moving from the server approach to service approach. When we ask people, at least till not very long time ago, you ask people whether you have electricity at your home, the answer would be usually yes. But what they mean is that they have a plug in the wall, and the electricity is actually generated by the electric plant far away out there. And till recently, when you ask people whether you have a computer at home or you have some storage disk at home, and the answer was also usually yes. But what they mean is that you have a box under your table that you need to buy, you need to manage, and so on and so forth, and that's your computer, that's your disk. But essentially, there is no much difference between electricity as a service and computing as a service, and that's what cloud computing is all about. Now, when you want to create such a service, it means that you need to take multiple pieces of hardware, let's say, or multiple resources, and assign them or chain them, these microservices, together to create the application or create the response to the request of the client. And now it becomes fairly tricky things. If you think about analogy of the autonomous cars, today the car spends about 95% on parking, but it's very clear process. Okay, I leave my car, I lock it, it stays in the parking lot for whatever it takes, then I come back and I pick the car. So most of the time, actually, car does nothing. When we go to the autonomous cars or on-demand cars, then basically I'm asking for a car and it shows up in a minute in the place where I am. So now you need to connect between these things and manage these resources. The same thing in the data center. When I'm looking for some sort of service, there is a multiple resources that need to work together in the chaining to provide the services. That's what data center is about. It's taking multiple resources and being able to configure them in a fraction of a second to respond to the request from the consumer. Okay, so we'll talk about cloud. Do you know when was the first cloud download? First download from the cloud. It's not a new concept at all. Okay, it happens about 3,500 years ago when Moses brought the scripts. Those days, cloud was pretty, not as advanced as now. I'm not talking about cloud. I'm talking about the interface. It was single user. It took a day to download 10 sentences. Not that huge. But now we are talking about cloud as a service provider. So in order to make it efficient, again, we talked about thinking outside of the box or sort of non-linear thinking. Long time ago, the communication was like pigeon mails. So if you want to move more data with pigeon mails, and you think this is pigeon mail as the concept, you can move more data, you can move faster data, you can find faster pigeon. Okay, this guy can probably pick 2 scripts at a time, and it probably flies faster, but it doesn't inherently changes the way you communicate and you work. With the new technologies like video conferencing, it is not just faster than pigeon. It enables to do things that you could not do before. Today, we can have an interactive meeting across the ocean, across multiple countries, talking with multiple people, soon even in the different languages with the automatic translation on the way. No matter how fast your pigeon flies, you couldn't do this. You can't do this with this technology. So you need to have a new technology, a new way of thinking, a new way of working. and then you can do things that cannot be done before. Now, we are in the networking business, and we deliver the networks that enables you to do more than you have done before. It enables you to do new things, more things. We worked with Oracle since 2002, and they actually internalized that using our network, the communication between different machines is not a bottleneck anymore. They rewrote their Oracle RAC system, and by moving from 10 gig networking to 40 gig networking, they got 50x performance boost. Not 4x, 50x. The reason is because they used their resources more efficiently. The other thing which is more recent is by using our networks, Baidu using NVIDIA GPUs and Mellanox interconnect, the first time they built a machine that the first time was classifying images or recognize images better than human. Today, computers can see better than humans see. The image recognition on the computer is better than the human, and the first time it happened in 2015 when Baidu built this machine using our network, and they couldn't achieve such results with any other network. So network is not just about efficiency on the interface to the application. It's not just about how fast you move the data between on the wires. It's also processing the data while it moves. In our most advanced network products, we have floating point units, actually computational units within every switch. So we can do the data aggregation operations on the fly, and actually when you ask for multiple results on on thousands of machines, you can get the end result from the network and not getting all the results and then figuring out on yourself. This technology actually is being used now today in the machine learning when we do the neural network training on sending different data sets to multiple instances of the neural network model, and after individual training, there is a consolidation of the training results, which is called parameter server. Usually it takes as much time as training itself, and by speeding up this parameter server by factor of 10, we can actually get down the training process from days to hours, or from weeks to days. So this is what our SHARP technology. SHARP stays for the scalable hierarchical aggregation and the reduction protocol. It's available in our most advanced network products today. So one thing that I will touch a little bit on the storage, and on the storage it has to deal with the efficiency of the storage and performance of the storage, and how we can deliver storage services to applications and to systems that are not necessarily advanced to take full advantage. So SNAP is the software-defined networking and accelerator storage processing. And if you look at the Ethernet cloud, Ethernet fabric, you have multiple machines connected to each to the network, and each one of these machines have its own storage, which is an application running on this machine uses the storage, and it's obviously not highly utilized because it's real hardware that is on this machine. You can use NVMe fabrics, which is the great thing to access the storage over the remote. The problem with this is that not all the computers and not all the platforms are actually ready and can take advantage of this. And there's an issue of the updating the software and the application and the APIs and the platforms. So it works, but then you need advanced technologies on each machine to take advantage of this. It's not always the case. So what if you could have storage services? You could be able to represent anything on your cloud as the really true local device. Not network-attached device that has some driver that presents APIs, that you can take that you can use, which implies some changes on the host. But you see on your machine, on the legacy operating system, you see the local device, but this local device somehow magically can touch everything. So what we deliver this with our SmartNIC technologies. Bluefield can represent or present, to the host, to the operating system, the local device, and it can, software that's running on this machine can actually allocate resources from different machines on the network and make them available as the local storage devices or local storage services resource on the local machine. So this way, utilization of the storage goes up. You can actually utilize, and you can even thin provisioning, you can oversubscribe your physical storage resources, and it still works. We have pilot projects with the major cloud providers right now, and they hopefully will move to production with this either this year or next year. So by using the advanced interconnects, and that's again about the efficiency of the interfaces and efficiency of how can you access your resources from one machine, from one physical machine to another, you can actually have a much more efficient, much better utilization of your resources. And again, it is about service chaining. I have a multiple stops, multiple microservices that needs to be chained together to deliver services my application is looking for, and this is one of the technologies that enables to do it. Okay, so these things are usually called virtualization. We virtualize the resources this way or another by abstracting out the physical infrastructure from the application. And as with this analogy of the power plants, then before the power plants, there was no workers at the power plants. Now, once we build these things, we need to invest. And we need to invest computing resources to manage the physical resources and to run actually this virtualization layer. So if I had my machine that I could use all the compute cores to applications, now part of this computing is actually need to be invested in virtualization. So now my machine becomes less efficient from the application perspective because I have lower computing power. Fortunately enough, all these things can be optimized by offloading fairly significant part of the virtualization operation to the hardware, to network adapters or to the storage, but still some part is out there running on the compute server. This would not be a big deal because this is a really small part. The problem with this is security. Today, crime, you don't need to really rob the bank and go with the guns to the bank. You can do it. You can get much more money if you're doing crime online, and therefore the security becomes even bigger topic. So when we talk about the classical enterprise data center, this is the security model. There was that based on the fact that in the enterprise data center, the owner or IT manager of the data center has full control of all the software that's running on the data center, all the applications running on the data center. So you have a security policy on your machine, and you have the application that are not going to do any harm because you know this application. And only thing you put is you put the firewall on the edge of the data center so the bad guys would not come in. This is the M&M model, which is hard on outside, soft on inside. You have a peripheral protection on the periphery of the data center, but inside the data center, it is not protected. Your data center is unprotected. If somebody gets inside, and there are some data centers that are protected, sometimes this firewall is actually implemented with the people with the machine guns, like in the power plant. There is no connection to the internet, so it's firewall with a real fire. But once you have this control, you are good. In the cloud, the things are changing. Okay? You have a security policy running on the compute server, and you have multiple applications. Unlike the enterprise data center, where you have full control on the application that's running on your machine, and you are deciding as the IT manager or CIO, you decide whom to run on your machine and whom not to run. On the cloud space, we are inviting other applications which we have no control on to run on my machine because I'm actually sending MIPS, right? So I'm bringing the new applications and to the customer application, and this server running on the same machine that runs my security policy. Now, what may happen is that one of these guys are bad guy. And the problem with this bad guy, that once he runs on my compute server, it can actually take over the security policy. Once he took over the security policy, he took over my data center. So data center is gone. Data center is compromised. Entire data center is taken over by single guy that I invited to run on my machine. He took over the security policy on the machine that he was hosted on, and now all the data center is under his control. If you think it's not possible, it is possible. Okay, there is a 30 years of history of host-based security problems. Till 17, actually, they were all based, like the Heartbleed is the most recent one. It was all of them were taking advantage of some sort of software bugs in the operating system that the bad guy could sneak in. These three are actually based on the side channel attack, which is not a software bug. It is taking advantage of some key characteristics of how people build the microprocessors. And this type of things happened on any operating system, on any processor. So in order to protect our infrastructure, we need to make sure that attacker and the victim are not sharing the same computing domain, that they're not running on the same computer. If you let attacker to run on your computer, no matter how good your operating system is, no matter what you are doing, but if you let other guys to run on your machine, you will be you are under the risk of being hacked. So, in order to make it work, what we need to do, we need to change the security model. From being soft inside, we need to make it hard inside. So every single machine on the computer, on the data center, must be protected. So we enable it, again, with our Bluefield technology that actually implements Snap as well. But what it does, it enables to run security policy on the Bluefield card that runs its own operating system, and it's not the application server. No one will get there. You can think about some sort of this network that connects these guys. This network is protected by the people with the machine guns. Okay, it's not network that is connected to the application network. It's not like the network is connected to the data network. There is no connectivity between this software and the software and the compute domain of the applications. So with the Bluefield technology, we can completely segregate the infrastructure computing tier and the application computing tier. And besides security, by the way, it has additional advantages. At the table in the breakfast, we talked about updates, software updates of various things. Some things it takes years and hundreds of thousands of dollars or euros to validate the upgrade. Here you can upgrade your compute server and your infrastructure compute server completely independent. They are not connected to each other. They're independent, and this way you both more secure and much more efficient in terms of operation. So these are sort of, there's on the tips of the things that we can take to the 2020 year and on, where we'll have billions of people connected and even tens of billions various devices connected that will require actually instantiation of the data center architecture all the way to the base, or to the telco, to the base of the antenna, to the self-driving car, to everywhere, all the way, even maybe to the smartwatch. Okay, to make sure that bad software that you could put on your watch doesn't compromise your watch operation or the data that's being collected as a watch. There's going to be much more applications, and again, the data. More and more data is being generated, more and more data will be available, and more things we can do. And $4 trillion of revenue opportunity. It's all out there. We just need to take advantage of this. Thank you very much.